About a year ago, I was at Eric O's garage together with Ivan, and I was showing Ivan one device that I made. And Eric O commented that can this device be used to test the ABS wheel speed sensor circuits, and so that you can confirm its integrity. And I thought, yeah, maybe, but with some effort. And only later on we've seen how Raymond from Kentucky Home Garage, I hope I pronounced his name correctly, showed how to use a picoscope, arbitrary wave generator, to test one particular type of ABS wheel speed sensor circuit. And then I had an idea, well, can this picoscope be used for other wheel speed sensor circuits? The ones that, for example, work with a digital square wave. And it's not directly, because picoscope arbitrary wave generator can generate only signals plus minus 2 volts, and the digital square wave sensors work at 0 to 5 volts, and other ones, the 2-wire ones, actually work a completely different principle when they actually modulate the current going through them in a certain range, and that wouldn't work at all. So this gave me an idea to build an amplifier for the Pico AWG, and also at the same time being a device to test the ABS wheel speed sensor circuit, all three types that I know of. So here is the device. It uses a 9-volt battery, and I can generate its own digital square wave, or it can accept the signal from the Pico AWG via BNC connector. So you have a selector over here, a slide switch that can switch between those two sources, and then it all goes to a circuitry that can either amplify that to the analog output, or it can actually use opto-isolators to drive circuits that produce either the digital 3-wire output or digital 2-wire output. I want to make it a do-it-yourself build kit so that people can just assemble it themselves. That would cut costs, and that's why the output that I've made is actually going on stereo cable, the good old stereo cable. So that would be easy to connect. Let's say in case of the 3-wire sensor, that would be power, the middle would be signal, and this would be the ground. And on the other side you can connect the test leads of your choice to them. For example, here I have the probe tips connected, very sharp, and also I use some heat shrink to insulate those, and also made the marking so that I have a power, signal and ground marked. Of course you have to be fairly careful with this because the wires are so thin, but for a do-it-yourselfer it's probably a very good idea, because it's very easy to get a long cable. You can easily get 15 feet of that cheap, and have the picoscope in one side of the room and the vehicle wherever you want. So what's going to follow is I'm going to show how this device works, and we'll see what kind of signals we are getting on all three outputs of this device. So stay tuned. One short note why I want this circuits to be opto-isolated. It's because I want to have a complete test of those circuits and do not want to accidentally provide power or ground from the device itself. So I want that to be completely separate. If for some reason there is no power coming, it wouldn't work. If there is no ground supplied, it wouldn't work. So everything would work only if all the circuitry in the ABS wheel sensor module works fine. So I hope that explains this requirement for the opto-isolation.